Okay, so this is the first lecture on energy. And so as we get started, we will say that our unit goal is to develop an emerging understanding of the problem of the concept of energy. And you have probably never seen a goal like this before because usually we want to understand things and not understand the problem with the things. And so the problem with the concept of energy is that it's really hard to explain what energy is. And I think scientists actually disagree about what energy is. I know physics teachers on my listserv certainly disagree with each other about how to explain what energy is. But hopefully by the end of the unit, we will understand why it's so challenging to explain what energy is. And but in spite of it being challenging to understand, we're still going to work with it. Kind of the best definition that I can give you is that it is the state of being of a system. Okay. Um, in order to help us kind of work with it, we are going to use an analogy, and we are going to use the analogy of money. And money is actually a pretty good analogy for energy. And so the first thing that I'm going to have you do is think about what you know about money. And so, how is money used and how does it move in our society? And so I want you to think about the following questions. How is it moved or transferred? What can you do with money when you have it? Why do you want to get money? Where is it stored when it is not being transferred? How do you get money? And kind of think outside the box. And you want to think about not only individuals but also kind of institutions or groups within society, because money is something that kind of permeates all levels of society: individuals, um, companies, governments, states, things like that. So we're going to think about money both from like the smallest part of society to the largest part. And so I have this visual organizer, and I want you to do two things with it. So you're going to stop the video and actually fill this in on your notes. I want you to identify places where money is stored in society. And so each one of these gray boxes can represent a place where money is stored. And so you should fill those out with your ideas about where it is stored. And then the second thing that I want you to do is to identify how money is transferred between these places and actually note it on your diagram. So stop the video and identify places where it is stored, and then between these places where is stored, identify how it's transferred. Okay, so there's really no like wrong answers to this, and you can be creative. Here are some things that people typically think of, but if you did not think of these and you thought of other things, don't worry. This is a very complex idea. So some places are Federal Reserve, commercial banks, and these are the banks that other banks use. Individual or consumer banks, individuals have bank accounts in consumer banks, businesses have bank accounts in consumer banks. People put money in their wallet, pocket, a shoe, under their bed. Money is definitely stored in the stock or bond market, real estate, stuff like that. Stores have money, like grocery stores, clothing stores, sports stores, and you probably have thought of other things. So these are places where money is stored in society. And again, I'm not going to be like really exhaustive here. We just want to get an idea of how money works, and then we're going to relate it to energy. And so some of the things I thought of about how money is stored, between the Federal Reserve and commercial banks, we can have electronic fund transfers, but we can also just have the cash. So like a Brinks truck, just could literally take the cash from the Federal Reserve to commercial banks. And then commercial banks, they also use the Brinks truck to take it to consumer banks. But I can again have fund transfers. Um, electronic fund transfers kind of work everywhere. Um, So business bank accounts, employers, they will give money to individuals through their bank accounts, like through automatic deposit or a paycheck. Um, and so individual bank accounts, they can cash checks and get cash and put that cash into their pocket, or they can use credit cards and pay for things at stores. They can have automatic deposits into stocks or the bond market. The stock or bond market can transfer if you get dividends, those can go right back into your account. Um, you can use cash from your wallet or pocket to pay for things in stores. Um, so there are all different ways to kind of transfer money around, but the big thing that I want you to understand is that this is all money, okay? So a misconception that you may have heard from your earlier teachers is that energy is transformed, okay? So it's like transformed into something else. This is actually the wrong way to think about energy. Energy is just always energy. And rather than thinking about it being transformed into something else, we want to think about it being in different accounts. Okay, so different accounts. And so I want to kind of drive this point home. When we go to the store and we buy stuff, the money does not transform into a loaf of bread. Okay, it does not transform into a loaf of bread. Well, okay. Or it does not transform, money does not transform into gasoline that I put into my car. Okay. Money is always money. All it is just it goes into one account or to another. So it can go from my account into the store account. It can go from my pocket to the store. It can go from your employer's account into your account, but it's always money. I can transfer it with a credit card. I can transfer it with cash. I can transfer it with a check. I can do a debit. So there are different ways I can transfer it, but it is still always money. So the same thing with energy. Energy really does not transform into different things. It's always energy. It just goes into different accounts. So this is one of the most important things you need to make sure your brain recognizes. It's always just energy. Okay, so some important ideas about money. It gives you the ability to do things in society. It's stored in different places and it's transferred between people and accounts, and you get money by working. So these are some important ideas about money. So how do these ideas about money translate into ideas about energy? Because money is our analogy for energy. Okay, so money gives you the ability to do things in society. Energy gives you the ability to do things or to change things in the universe. And you cannot change anything in the universe unless you use energy. Or if anything in the universe changes, it's because there's been a transfer of energy. Okay, so that's a really critical point. You cannot change things in the universe without having an exchange or transfer of energy. Okay, so bank is a system where money can be deposited, stored, or withdrawn from different storage accounts. Energy is stored or removed from different types of energy storage accounts. Okay, energy is added, stored, or removed from different types of energy storage accounts. And then working is transferring money from one person to another or a business to an individual. You're losing and gaining money. For our course, work is the only way you can transfer energy into or out of a system. So we have this idea that energy is always conserved, it never changes, and that's not true. Depending on how you define your system, you can have energy transfer or energy transfers in or out of a system by working. Okay, so that is how energy is like money. So working is transferring money from one person to another, losing or gaining. Working is transferring energy from one system to another. And our definition of work is that it's force applied over some displacement. So in order to do work, we have to have a force and we have to have an object moving from one place to another. Okay, different energy storage accounts. So these are the different types of energy storage accounts that we are going to be looking at in our course. So one is the elastic energy account. So if we have anything that's stretchy, like a spring or foam, that is energy that we can store, or that is the energy stored in an energy or in our UEL account. And we're going to measure the amount of energy in that account by the amount of stretch or compression of the object. We can also have a gravitational energy account, and this has the symbol UG. You can store energy in the Earth's gravitational field by increasing the distance between the Earth and an object. And so we're going to measure the gravitational energy account by the height from some zero reference point. We can have a kinetic energy account, and this is the energy stored in moving objects. And so we're going to measure the amount of kinetic energy in the kinetic energy account by speed or velocity. And finally, we have something called the thermal energy account. And this is energy that is actually lost due to typically friction. And so we will measure energy lost by temperature. So if you've ever had like a rug burn or if you've slid into home plate, you'll notice your leg or body heating up. That is energy lost to friction. Okay, so hopefully you noticed we had two symbols. One was U and one was K. So U is potential energy, and it's the energy of position, and it's always specific to a defined reference frame or coordinate system. And so I'll explain that in a minute. You have to have an origin and a direction of positive in order to be able to characterize the potential energy. And our notation can be either U or E. I transfer between different materials, and some materials use U for potential energy, other materials use E for potential energy. Okay, there are many symbols for energy because there are many types. We've seen just two, potential, which is U, and kinetic, which is K. But all of them are measured in joules, and the symbol for the unit is J. Okay, now we're going to talk about a way to represent conservation of energy through energy pie charts. And so I'm going to end this. Maybe I will end it. All right, we're going to go to energy pie charts. So the first thing that I talked about was UG. And we are going to imagine a table and a ball on top of the table. And I know if I drop this ball, it is, especially if it's a steel ball, I might be able to dent the table. And so the idea is that I am some distance h above my 0 point. So this is 0 equals h. I'm going to write this the correct way. So h equals 0. And so I have some energy associated with the ball being up here. And so I'm going to represent that. So this is state A is up here. And I'm going to have, and I'm just holding it there. And so all the energy is gravitational potential. Okay. So I can imagine a state B where the ball is in this location, and I'm going to call that B. Now, I've got to have the same amount of energy, so I'm going to do the same size pi. So, same size because energy is conserved. But if I think about this is HB, HB is smaller than HA, so that means my entire energy for state B, I've got less gravitational. So I'm going to divide this now. So I've still got some gravitational because I haven't hit the ground yet. But what is the rest of the energy? Well, it's actually kinetic because I know the ball is falling. So I'm going to do whooshies to represent the ball is falling. Okay. All right, we can do a state C. And this is just before I hit the ground. So this is state C. So again, I'm going to do the same size pi. I'm like so bad at doing the same size circles. All right. Same size pi because energy is conserved. So I know that the energy at A equals the energy at B, and it's got to equal the energy at C. Okay. But at C, I have nowhere to fall. I'm just before I hit the ground, and so my energy is all kinetic. Okay. All right, so that is pie chart 1. Let's do another example. Okay. For the second example, we are going to do a wind-up toy. So you know what a wind-up toy is. So I'm like really bad at drawing these, but we're going to do like a wind-up duck. Oh my gosh. Okay, that's my wind-up duck. And so a wind-up duck has like literally a thing on here, and I can wind up the spring. Okay. And so when I wind up the spring, I'm giving it a whole lot of of elastic potential energy. Wind up spring and hold. So that will be my state A. Okay. State B, it's moving along. I don't think I can draw this duck again. I could barely draw it the first time. Okay. So state B, it is moving. Again, we'll do whooshies for motion. So moving. We know that it has lost. That's probably too much. We know that it does not have as much elastic. And we know that it has some kinetic. But we also know that it is going to lose some to gravitational. I mean, not gravitational, sorry, thermal, because eventually the duck is going to stop. Okay, so this is eventually. It is stopped. So it doesn't have kinetic, it doesn't have elastic, and that means that all the energy, I need to make this a little bit bigger, because again, the pi sizes need to be the same to represent energy has not changed. So all the energy has gone to thermal, and so that's where all the account is. I've lost the energy, it's gone to thermal. Okay, so you're going to do a worksheet where you are going to do pie charts. You can do kind of as many states as you want. I usually suggest about 4. I know I've only been showing you 3, but I would usually do the object at like 4 different states so it's clear what's going on. I'll show you an example of what 4 states would look like for this. So here's my duck. Wind-up toys actually move at a constant velocity. And so as this duck moves, the kinetic energy has to stay the same size because they're constant velocity. So that means I've lost elastic, my spring is winding down, and all of this is thermal energy. So if you have questions about this, please don't hesitate to ask me.